Physics 2212, Lab 4, Circuits and Capacitors. The purpose of this lab was to predict the behavior of circuits containing resistors in series and parallel, use ammeters and voltmeters to determine current and potential differences, analyze behaviors of ohmic resistors and capacitors. The fundamental principles used in this lab were the loop rule, node rule, and Ohm's law. Loop rule states that potential difference around a loop sums to zero and the energy is conserved. Node rule states that current entering a node is equal to the current leaving a node and charge is conserved. Ohm's law is current is equal to volts divided by resistance. Now the first simple circuit was a series circuit. You get the volts by adding together the volts of the two batteries, 3 volts. The resistance is done the same way at the resistance of the two resistors. The current is found by dividing the volts by the resistance. And the calculations I made matched the ones in the simulation. Now this unclosed circuit is going to read 0 on the ammeter because no current runs through it. The voltmeter, however, will read -3 volts because the potential difference must sum to 0 and the battery produces 3 volts. Therefore, -3 is needed to make it 0. And then I recorded the resistance for the 47 ohm resistor, the 100 ohm resistor, the wire, and the battery, and the potential differences between those as well. And then I have a graph on the right. Now this parallel circuit, the current will go through the ammeter instead of the resistor because it wants to take the path of least resistance. And because of this, the ammeter will read 0.6 amps. Because in this new circuit, the only resistor it goes through is the 47 ohm resistor. In this RC circuit, current flows through the circuit until the capacitor is fully charged. While it's charging, the bulb will light up. Once it's fully charged, it'll stop lighting up. Charge time for the 10 ohm bulb was 19.81 seconds. For the 20 ohm bulb was 40.24. When I take the battery away, the capacitor will discharge all of its stored energy, lighting up the bulb until it is fully empty. The discharge time for the 10 ohm bulb is 19.93 seconds. The discharge time for the 20 ohm bulb is 40.36 seconds. These are results from my calculated RC. They were very close to the expected results, which is understandable because there could be small errors in my math or in the simulation treating it as ideal versus a real situation. Now, what if I used a real ammeter? If I use a real one, they have resistance to them because it's real metal on metal, and this will cause a slightly lower current reading. And same thing if I used a real battery. They also have resistance to them, and this will cause the capacitor to charge more slowly. An ideal capacitor will become fully charged immediately, but as we know,